Hey guys, so today we're going to learn the algebraic lesson of simplifying radicals.
So a radical is any equation containing a radical symbol. A radical symbol includes squared and cubed roots. So how to simplify? No, okay.
Okay, so how to simplify the radicals. In order to do this, you
Find the prime factorization of the number inside the radical and factor each variable inside the radical. This is also an example of how to simplify radicals.
Okay, so here, to walk you through this example over here, you're finding the rad of 12. And so 4 times 3 equals 12, so that's breaking down inside the radical. And then you split this in half, so to say, just to make it visually easier. So it will be rad 4 times rad 3. And then 2 times 2 equals 4. And any 2 of something comes out of the rad as 1 of something. So it would come out as 2 rad 3 because there's 2 number 2's inside the radical, and they come out as 1. So pairs come out as one individual set of numbers. Okay, so to start with the example, we're going to do the odds only, but if you guys are more than welcome to do the evens if you would want extra practice. So just so you guys can kind of get a handle on it, we're going to start with these top 3, just so you can kind of see an example, and I'll do all 3 so you can understand what's going on. So in 72, the 2 factors to break down 72 are 36 and 2. Okay, so to get the square root of 36, it's 6 times 6. And because there's 2 6's, like this, it would come out of the radical as 1 6. So your answer would be 6 rad 2, because there is no square root of 2. And 2 is also a prime number. So then going on to 48, it would be 16 times 3. And again, 4 times 4 is 16, and that's 2 number 4's, so 1 4 comes out of the rad, so it's 4 rad 3. And then finally for 125, it will be 25 times 5. And then again, to be repeated, 5 times 5 is 25, and there's 2 of the number 5. So 1 5 comes out of the radical, so it's 5 rad 5. Okay. So then going in to the first one, it's rad 18. So for rad 18, it's 9 times 2, so it's rad 9 times rad 2. The square root of 9 is 3, and so it would be 3 rad 2 because the square root of 9 comes out of the radical. Again, you're welcome to do the evens if you want more practice. So for example number 3, for 72, it's rad 8 times rad 9. Okay, so to make this simpler, you would do, so the 9 will come out as a 3, and the 8 comes out, oh, just kidding, it's up there. You could do 36 and 2. I made it more complicated. You guys don't have to do that one. Okay, so for number 5, this problem's a little different because it has a variable, as you can see. It's just an a, it's not just a number. So you're looking at the cubed root of a cubed. So when you're dealing with a variable that has an exponent like this, what you do is you need to separate it into its parts. So a cubed, the cubed root of a cubed is the square root of a 3 times. So it will be rad a times rad a times rad a. And the rule still pertains. You're looking for pairs when you're dealing with the variables as well. So these 2 a's right here eliminate to form 1 a outside of the radical. And because there's 1 a left over, it becomes a rad a. Okay, moving on to number 7. It's m to the 11th. Again, you would do the same thing with the a's if to eliminate how many are left over and how many you can take out. But to save time, there would be 5 m's left over. So it would be 5m rad m. But of course, it would be the same thing as a, where if you really wanted to work it out step by step, you just write out rad m 11 times and group in pairs to figure out how much comes out. Okay, so moving on to number 9, I'm going to have Abby come and help you out with this one.
Okay, so for this one, you're going to have to find the multiples of 27, which are just 9 and 3. So since 9 is the square root of 3, you can just put 3, rad 3. These are also just multiplying. And like in number 7, instead of writing out m 11 times, there are 5 pairs of a here. So you just do 3, 5a, and then we're going to have to make room for another variable there. So inside you still have 3, you have another a, and for b there are 3 pairs, so we have 3b, and there's 1b left over, so it's rad 3ab. For number 11, the square root of 9 is just 3, and the square root of a to the 8th is just a to the 4th. Or just, sorry, wait a minute, just a to the 4th, yeah. And I am so sorry, these numbers here is not 5a, it's actually just a to the 5th, b to the 3rd.
Abby's a little confused, but hopefully you guys get the point. That's similar to other examples that we've done.
And for number 13, the square root of 36 is just 6, square root of x squared is just x, and then y to the 6th is just y to the 3rd. And finally for 15, this one is...
So notice this one's different because it has a negative. It's a negative with an invisible 1 outside the radical.
So the factors of this are 20 and 10, and the factors of 20 are 10 and 2. So this is rad 10 times rad 2, and this is just rad 10. So if we have 2 rad 10s, we can just put the 10 on the outside of the rad sign and still have the rad 2, but since it is negative,
it would be negative 10 rad 2. Okay, so we have some example steps for you just to kind of review the process. So the first step would to be find the factorization of the number inside the radical. So example 252 is 2 times 2 times 3 times 3 times 7. So you can take 2 and 3 outside of the radical because they're in pairs. Step 2 is to determine the index of the radical. In this case, the index is 2 because it is a square root, which means we need 2 of a kind. So again, breaking down the steps that I said from here, there's 2 of them, so you can pull those out of the radical. Step 3 is to move each group of numbers or variables from inside the radical to outside the radical, if you can. Don't move everything if you can't. In this case, the pair of 2's and 3's moved outside the radical. So you would do 2 times 3. So to simplify the expressions, both inside and outside, you multiply them. So it wouldn't be 2 plus 3, it would be 2 times 3, which will give you 6. So that's just a brief overview of what we learned today, and we hope you guys enjoyed this lesson. And if you have any questions, hopefully these notes helped you remember how to simplify radicals. Bye!
Real-world example. The diagonal of a square can be expressed by the formula d equals 2a, where a is the side length of the square. If the side length of a square is 5m, what is the length of the diagonal? Round your answer to the nearest tenth. So d is going to equal 2a, which is going to be 2 times 5, which also equals 7.1. So 7.1 is our answer.